Okay, so this is video 3. So I've either been interrupted twice, or I've made a couple of mistakes. Don't assume that screwing up the paper noise was me making a mistake. So Bilal invests £4,000 into a saving account for 3 years. So if it was a normal compound interest question, we'll be doing 4,000 times by a number to the power of 3. So that's what it could be. But this is a slightly weird one. The account pays an annual interest of 1.5% for the first year, and then it changes to X for the second year and X for the third year. So we don't know the interest rate for the last 2 years. Okay, so we know that in the end though, there's 4,141.61. So we know kind of what the end game would be, the actual value was. So we're going to use that to work in reverse to find these two percentages here, to find this missing interest rate. So what I'm going to do first is calculate how much you get after year 1, because we can do that. So because it's a 1% increase, it would be 100% add 1.5%, which is 101.5%. As a multiplier, that is 1.015. Okay, so you can see the 0.15, the 0.05 has been added to 1. So that's my multiplier. So I'm going to do that, and I'll get some credit, and it'll give me that. So that's after year 1. Okay, then this value has now been used again, and it's been multiplied by something we don't know twice because it's 2 years, and that has worked out to be this new value. So what we need to do is unpick this and rearrange it. So when we've got formula to go, you can rearrange. So let me just take you through how I've done this. This is the value, this is the money after year 1. And compound interest, we multiply by the multiplier, we don't know it, to the power of the number of years we're going to do. So we've already had a year on the go, and that means there's only 2 years left at the moment. So these are the last 2 years. So I'm going to pick it. So I'm going to get rid of the multiply first. So divide by 4060. So x squared equals this. You can see it, just keep it in your calculator. Okay, and I'm going to keep the value in my calculator. So when I'm doing my working out, I'm not going to have any rounding errors or anything like that. Now I've got x squared, I actually want to square root that. So x equals, and this is why it's a good idea to keep it in the calculator. So just press square root and equals. It'll sub everything in for you. So equals 1.01, and because it's so fine down here, you can ignore that. So it's 1.01. Now, because of our knowledge, this is saying that this multiplier is 1.01. So we have to understand what that's showing us. What that's showing us is that it's a 1% increase. Just like this was a 1.5% increase, was using 1.015. This is 1.01. So if I turn it back into a percentage, it would be 101%. It's actually gone up by 1% a year. Okay, so it's a very good question for our practice questions. And this paper's full of loads of good questions to get you ready. And if you can understand these questions, like after the first couple of weeks when you get back from half term, you're going to do really well in the PPEs and the mocks that are coming up, because they're really unusual, and it's the same people who are going to write your mocks as well. So it's really worth you doing these quick videos properly and really taking what you can from them. So a different type of percentage question. The cost of a jacket decreases by 12.5% in a sale to 140. So it's decreased. Work out the cost of the jacket before the sale price. Now, the non-calculator way to do this is to take this off of 100 and to find out what percentage you've got left. Find out a nice easy percentage to calculate with and try and make 100%. The calculator way is a little bit easier. So we're just going to have a look. So we had 100% and we are going to take away 12.5%. That is going to leave 87.5%. Okay. This, as a multiplier, would be 0.875. And something we don't know was multiplied by 0.875. So this is the cost of the jacket. And that was equal to 140. So what we do is then divide by it, and we call it a reverse percentage for a reason. It's the reverse process. We're not going to multiply with it, we're going to divide. Like that. And if we're doing it right, and it should work out because we're dividing by a decimal, a number less than 1, it should work out to be bigger. So 140 divided by 0.875, I've got 160. You do not work out 12.5% and add it back on. That's not what's going on. It has been reduced. You need to figure out what it was reduced by. Okay, what the original value was, sorry. So there you go, that's the process. We're using the multiplier and dividing instead. So divide by the multiplier. Always work out the multiplier, then choose what to do with it. Right, this one. I have to say set 2 did really well on this one, and if you didn't, it was because you missed out on key little things. So BCD are points on the circumference, points on the circumference of a circle or centre O. So it's saying that's the centre, and these are touching the edge, the circumference. Okay. You can hear the corridor noise there. Enjoy that. Yeah, hopefully you're using that to your enjoyment. Anyway, AB and AD are tangents to the circle. So when I'm thinking tangents, I know that they meet radius at 90 degrees. There could be a triangle on them. There's not a triangle on this one, which would be alternate segment theorem. So there's that. And DAB is 50 degrees. Work out the angle BCD. So that's this little angle right here. There. Okay. And we have to explain our reasoning. So we have to say every single fact that we're using. Just so they know what's going on. So I'm reading emails at the same time. I shouldn't really read emails now. Okay, so let's see where the starting point is. The starting point is the own angle you've been given. There's no other information. You don't know this angle to help you get the pink angle there. There's no diameter, so you can't put a 90-degree angle in a triangle or anything like that. So it's all about this. Okay, and in this shape, we can see the kite shape, which is useful. It's a 4-sided shape. But that is made up of 2 radiuses, or 2 radii, and then meeting these tangents. And radius, or radii, meet tangents at 90 degrees. So, what is it? ABO and ADO equal 90 degrees. Okay, so that's these two. They're 90. Okay, so I'm going to put them on and just write the values in so I can see them as well. Okay, so those two are 90. And I've got this shape on the go. This 4-sided shape. And I know that angles in a quadrilateral add to 360 degrees. Okay, so that's what I've done there. So DOB equals 360, take away the 2 90s and the 50. Okay, and that will boil down to 130. So that's 130. Okay. So that's what I've been able to get from that information. I can't find these little bits here, but I've now got an angle at the centre. And the question was saying that these are all touching the circumference. And there is a relationship between the angle at the centre and the angle at the circumference. The angle at the centre is double the angle at the circumference. So I'm going to write it down. So angle at the centre is double the angle at the circumference. Okay, so BCD equals 130 divided by 2, because I'm going the other way. So it's half of it, so it's 65 degrees. Okay, so just look at how I'm doing it. There's a fact, there's a calculation. There's a fact, there's a calculation. There's a fact, there's a calculation. They can never deny me the marks, and I've labelled my angles as well, so it's really clear what I'm doing there. Okay, so that would be a perfect answer. Right, this one is a tree diagram. All the rules of tree diagrams apply. Okay, it's just an irregular question. Okay, so probably Rebecca will win any game of snooker is P. She plays 2 games of snooker. Complete the table in terms of P. So let's have a look. If that's P, all probability will add up to 1. If it's a fraction, you just keep the same base and you add it to 1. So this is not this and this add to 1. So this is going to be 1 minus p, because both of them should add up to 1. So if I take that off of 1, it'll give me this one. So it's just an awkward one. And because the diagram, because the situation doesn't change, the probabilities don't change either. That's how they're going to stay. So we've got that so far. And because it is a tree diagram, I'm going to continue to do the steps that I always do. I'm always going to work out the probabilities here right now before I answer any question. Okay, so with tree diagrams, you multiply the probabilities that way, and then if I need to combine any probabilities this way, I'm going to add them together. Okay, so that's what I'm going to do. I'm going to multiply. So this is going to be p times p, which is p squared, not 2p. Some of you made the mistake with that. This one is going to be p times 1 minus p, which is p minus p squared. This one down here, so going this way, is it's 1 minus p times p. So it's the same as the one above, and we'll do it algebraic like this. So p minus p squared. So I've got that, and the last one. The last one, I'm not going to expand it just because it might be a double bracket, and I don't know if I need to do it yet. That'll be enough for now. And if I do have to expand it, then I'll just expand it. I'll just have to read the question. Okay, but I've multiplied the probabilities, and before I've even answered this, I know I've already got at least a mark because I've shown that I know how to multiply. Multiply, multiply. Okay, so write down an expression in terms of p. So write down your answer with p's for the probability that Rebecca will win both games. So this is just can you read a diagram. So win and a win is p squared. Okay, because we just followed the diagram. Next one, write down an expression in terms of p for the probability that Rebecca will win exactly one game. So if I go down the bottom, she's lost both games, so I didn't need this double bracket in the end, so I'm not going to bother expanding that double bracket in the end. But there are different options for this, so you can win and lose. So I'd need this one. You could lose then win, so I need this one. And like I said, if you need more than one, then what to do with them is to add them together. Okay, so that's what I'm going to do. So I've got, this space was for working out, but we've nailed it up there. So I've got p minus p squared add p minus p squared. So I've got p add p, which is 2p. And I've got minus p squared and a minus p squared, so that's minus 2p squared. It is unusual, and there's a question that came out in the press when they did it in the actual exam, that it was too hard. But it's not too hard if you understand the rules. And if you're really regimented, if you do this all the time, you'd still get credit down here, whatever option you put down here. Okay, so some people got p squared at the top because you followed the diagram, and you got some credit anyway. So sometimes the questions will be weird, but you have to apply kind of the things you know about it and get some credit, whatever, even if you're not going to get full marks. But this is doable. And if they try and give you a question like this in the exam, I'll be looking forward to it because hopefully we'll practice it by then. Okay, this one, my class in particular have not done it. Okay, it's going to be the actual intervention stuff that we're going to do today. It's Friday today. I'm just trying to get this video done for you. Okay, and it's algebraic proportion. It is nice and straightforward. You just need to understand what to do and remember the relationships that they're talking about. So x is directly proportional. So I'm going to do this. X directly proportional. I don't do the little symbol for the fish. I just get straight into the equation. To the positive square root of y, to the square root of y. So it's saying that x is directly proportional, so x equals something times by the root of y. You have to remember that this is how you set it up. Okay, some people draw a little fish and I'm not interested in that. I'm going to go straight into the format. So when x is 2, so when x is 2, and this y is 1 over 25, so they're actually multiplying each other now. I've just kept it, that's the formula, but now I'm going to turn it to values, I'm going to multiply. So the square root of 1 over 25. And that's a really good question. It's going to teach you how to square root fractions, okay, because they're simpler than you may think. So 2 equals k times, and the square root of a fraction, you literally square at the top, which is going to be 1, and you square at the bottom, which is going to be 5. Okay? And now I've got to try and get k by itself, because I want to reset this, I want to set this relationship back up where k is actually a number, so I can figure new things out. So I'm going to get rid of this a fifth. Now the fifth is actually dividing k by 5. So to get rid of this 5 on the bottom, I'm going to times by 5. So k actually equals 10. And what that means I can do is apply that into the original format. So x equals 10 root y. And now this is a little function machine, or a little formula that if I'm given x, I can find y. If I'm given y, I can find x. And I've actually been given y. It says y is 16. And I can put that into my little formula, and I can find x. So x equals 10 times the square root of 16 now. So x equals 10 times 4, so x equals 40. If you've not done it before, it'll seem really weird, but once you get through the experience of knowing how to set this bit up in the process, it's a nice little one to remember. They've just been awkward by doing this, okay? And I didn't use my calculator at any time. I could have done, and this process of doing this would have still given me the same values, but it is like kind of a non-calculator subject, and they'll do that on calculator papers, okay? Because you can't, people think you can rely on these things for everything. You just can't. You have to understand the structure. Right, bottom one. Now, if I just like ignore the question and I see that, I'd be going up for double expansion. I'd just do the double brackets now. I won't wait, I'd just get on with it if you're not sure what it's asking. But this is saying, if I've got to prove algebraically that when I expand this, or whatever I do with this, I'm proving that it's a multiple of 8. Okay, so there'll be like the number 16 in there, or 24, or 80, or something to do with 8 will be my answer after like evaluating this, after expanding all this. Okay, and some of you didn't read the word that it really goes for, algebraically. All it means is you use your algebra skills to these and see what comes out of it. So I'm going to do this bit here. So 2n plus 3 squared is this. Some of you forgot that. This minus is actually on this whole bracket. So I'm going to contain all this in square brackets for now and do 2n minus 3 inside the square brackets and deal with this minus later. Okay, so you'll see what it looks like. So this, I'm going to expand really slowly. So it's 2n times this bracket, so 2n times by that bracket, and then 3 times that bracket. And just expand this, so 4n squared plus 6n plus 6n plus 9. Take away, keep these in square brackets. 4n, I'm missing a step here, I'll do it here. So 2n times by this bracket, 2n minus 3, and minus 3 times by this bracket, so minus 3, 2n minus 3. So I've got now 4n squared minus 6n minus 6n plus 9. Okay, so just being aware of my little roots there. And now this minus can come out. But what happens, I've got to apply it to this. So it's probably best if I simplify these down a little bit. So this is actually 4n squared, add 12n, add 9. And inside I've got 4n squared minus 12n, add 9. And this minus is basically multiplying all this by -1. The signs are basically going to change. So I've got 4n squared plus 12n plus 9. This is a 4n, so it's going to become minus 4n. This is negative 12n, so it's going to be plus 12n. And this is plus 9, so it's going to be minus 9. Okay, and now it's a case of eliminating the things that we've got. So we've got 4n squared and minus 4n squared. They are going to cancel out because if I've got 4 things and I take 4 things away, it's gone. I've got 12n, add 12n, which is 24n. So that's then done. And 9 take away 9, cancel out. So I'm left with 24n. So which is good news because that is related to 8. And if I think about it, it's actually 8 times 3n. If I wanted to break it that way, I could say 24 is in the 8 times table. I could leave it like this, but I have shown that it is a multiple of 8. Okay, so that is it done. Right, this one. Again, we need to confirm whether or not it is in the new exam or not. It's come up a lot, so I'm going to assume for now that it is and make sure you understand how to do this. So we have 0.35 recurring. So I'm just going to do a bit of it. And we have to prove that it can be written as 32 over 90. So we have to do an algebraic proof, or a systematic way of doing this with not just typing that into our calculator and proving it that way. This is the format. So we're going to make the recurring decimal equal to x. What I like to do is I think how many numbers are recurring. There is one number recurring, so I'm going to multiply by 10. Okay, so multiply by 10. What that'll do, it'll shift all the numbers down one place. And imagine these 5s that are going on forever and ever and ever. They've just lined up in my equation. So all these 5s that go on for infinity are now all lined up together. So if I have something and I take the same something away, it doesn't matter how big it is, it's going to disappear. So what we're going to do is take them away, and what that does, it eliminates the recurring part of this decimal. They've gone because they're taken away from each other. Now I'm going to work this out. So if I take away 3, it's 2, 3 take away nothing is 3, and I've got 10x take away x, which is 9x. Okay, and now I'm going to divide by 9 because I want x to be by itself. But that is an improper fraction. You can't have decimals there, so we're going to remove the decimal part. To do that, we'd have to multiply this by 10. So we're going to do the same to the bottom to keep it equivalent, and that will be 32 over 90. And therefore, I've proved algebraically that that recurring decimal can be written as that fraction. Okay, they're looking for this. If it's not there, you've got it wrong. Okay, so it's an easy process to learn. It's all about understanding what to multiply your line by. Right, the next one. Algebraic fractions, factorise. You're going to have to factorise. If you don't factorise, you're going to find it too difficult to do anything with it. Okay, you might get a bit of credit for actually showing that you understand how to divide fractions, but it's all about factorising. One of them is easy to recognise as a thing. So if I just zoom a little bit, this 4x minus 25 is the difference of two squares. It's called dots to us. The difference of two squares. 4 is a square number and x is a square term. So that's a square thing altogether. That's a square term altogether. Take away a square number. So it's the difference, because it's take away, of two squares. That's a square thing and that's a square thing. They're easy to learn how to factorise. Straight away, I can do the square root of 4x squared, which is 2x. And they go in there. And the square root of 25 is 5. And it's plus and minus. If you did do the long way of factorising, you do 4 times 25, which is 100. You do the factors of 100 that have a difference of 0. So it'd be the same number. And that would cancel out at some point when you actually simplify. But this is a nice easy one to recognise. Okay, so you can factorise just the same as this, but you'd be looking for 0 in the middle. So a strategy would be to write it out again. So it'd be add 0x minus 25. And you could split the middle, and you could still do the same thing, absolutely, and it would work out. This I'm going to have to factorise properly. So to factorise, we want to split the middle. So we're going to do the front times the back. Let's get minus 60. I'm going to do all the factors of 60. And with a calculator, this job is dead easy. So you can't miss any. So just do 60 divided by 1, which obviously works, is 60. Then 60 divided by 2, so it's 30. So we've got 2 and 30. I mean, some of you will know these. So I know them, so I'm going to write them out. But what you do is just keep dividing lots. So 60 divided by 4. 60 divided by 5, and it'll give you your factor pairs without you having to stress over it. So 60 divided by 6, and 60 divided by 7 is a decimal, so that don't work. 60 divided by 8 don't work. 60 divided by 9, 60 divided by 9 don't work. And 60 divided by 10, well, I've already used 10, so I've got it. So you can see that I was just testing out the numbers, and you can see they don't work. So that's all the factor pairs considered, and you must do that, okay? That's not an option. And because it's a minus, I'm going to try and do this, it's the difference of the middle. So a difference of 11. Okay, so which ones have got a difference of 11? So that's got a difference of 59, 28, 17. So these two have got a difference of 11, 4 and 15. Okay, so I know I'm going to be breaking this middle into that. So let me get some space, do that here. So rewrite the original quadratic, and then we're going to split that middle. Now we need to make minus 11x using 4 and 15, so minus 11. So it means the bigger number is going to be the negative. So I'm going to have minus 15x. I'm going to put that first on the left, and then 4x there. That is the same as minus 11x. I've just split it so I can use it differently. 6x squared just comes down, and minus 10 just comes down. And now I can factorise each side. It's a much easier way to factorise this and that compared to doing this thing all together. Okay, so think about what's common to 6x squared and 15x. Just doing 6 and 15, I've got the 3 times table. Doing x squared and x, they both have x inside. That would need to have 2x to make 6x squared. 3 times 5 makes 15. I've already got x on the outside, so 5 times 3x is already 15x, and there's a negative in the middle. This one, common factor for 4 and 10 is 2. I was already thinking about my answer. There's no bigger value. That would give me 2x minus 5, which is what I'm looking for, because these need to be the same, which is nice. We collect the bracket to just make it one big bracket on its own, and it's almost like factorising again. So if I get rid of these, because they're common, it shows me what's left. So 3x add 2 is left. And now what we're going to do is bring this all together into one thing. Well, I haven't even done this bit yet. Oh, best do this bit. So I'm going to have 1, and then I've got 2x minus 5, 3x plus 2, divided by, what was there, 1, 2x plus 5, 2x minus 5. I'm really annoyed that I've done this line now, it's in the way, it's frustrating me. And to divide fractions, we don't actually divide a fraction, we're just going to multiply instead. So we're going to multiply instead. So I'm going to do 1 over 2x minus 5, 3x plus 2, multiplied by, and this is where you flip this fraction, so 2x plus 5, ignore this blooming line, it's in the way, like that. And now it's like that when we multiply fractions, and you see it's sort of crossing the eye. This cross is sort of giving my brain a little reminder. I can cross cancel. Okay, so think about this multiplication sign. I can look that way and that way, and that way and that way, to see if I've got anything that's the same, to get rid of it. So I'm going to get rid of 2x minus 5 on there and there. I mean, I could eliminate the ones, but that's pointless. But what would happen when I multiply fractions is the tops times together, so it would be 1 times that, so that'll be just 2x plus 5, and 1 times that, so that'll be 3x plus 2. And that's finished, because I can't factorise these, and that's what I'm left with. So if I look at what I was after, you wanted something x add b, something x add 5, so 2x add 5, and something x add d, something x add d. So you can see it's in the right format, so I finished. I mean, that is a really tight question for 3 marks. I'd expect more than that. I'd expect 2 for this factorising, 1 for that factorising if you knew that one, 1 for understand that you should multiply, and 1 for actually doing it. So I reckon it should be way more than just 3, but that's the way it goes. Okay. Right then, find the length of AB. So AB is there. It's saying that this is a sector of a circle, radius 9, but it wants that. And that is the length of an arc, okay, which is a fraction of a circle. If you drew a big circle, you'd have this, okay. It's asking for the length of the arc, which is a bit of the circumference, and for me, pi r squared sounds like area to me, but when I need a circumference, I'll use pi d, so that's how you find the circumference, pi times the diameter, and so I'll be using that. But this is a fraction of the circle, it's only a little bit. The fraction of the circle is actually 55 out of 360 degrees. That is the fraction I know. If I multiply by that by pi d, it will give me what I'm after. Pi d will give me the full circle's circumference. This will give me a little portion of it. So the calculator, it'll be 55 times 360 times by pi times by the diameter. So this is the radius. The diameter for a full circle would be 18 because it's a full circle, so that's only halfway. So times by 18. Okay, so that looks like this. So 55 over 360 times by pi times by 18. And we get that. So you get 8.63937, blah, blah, blah. And it wants it to 3 significant figures. So significant figure, start from the front. I'm going to go up to there. First 3 values that are not 0. It's either going to be 8.63 or 8.64. Because this is a 9, it's going to go up to 8.64. It's a nice, easy subject to learn. It's a fraction of a circle. And when you remember that, it's quite straightforward to do. So it just goes into the calculator. You get it from there. Right then, this one is a difficult bounds question. It's as difficult as they get, okay? But it is doable. And the thing to remember is when you're dealing with bounds or accuracy, is to do the bounds bit first. It's really annoying that you will do the calculation first, then do the bounds. It's more important that you do the bounds first. Okay, so let's have a look. So these are the values rounded. By considering your bounds, work out a value of G to a suitable degree of accuracy. So it wants you to do the maximum value and the minimum value and see what you reckon is a good answer to round to after looking at those two. So I'm going to cover this back up because I don't want to do any calculation. And I'm going to get rid of that because I don't want to do any calculation with that yet. I'm just going to focus on that. Okay, so that means I just need to read it. So 25.42 is rounded to 4 significant figures. So the last one is the 4th one. Okay, so that means it was rounded on the end. So I'm going to go 25.42 and increase the end by 1 to 25.43. 25.4, I'm going to come down 1. And it was just knowing that it was the end one that went up or down. Okay, so then go in the middle. Basically, this left one grows a 5 on the end. And this one grows a 5 for this one, so 25.425. So that's your lower bound and your upper bound. Okay, that's that considered and done. Let's do the next one. So 7.234 is corrected 3 decimal places. So the 4 was where it was rounded to. So it's the 4 that's going to go up by 1 and down by 1. So 7.234, 7.235, 7.233. And again, this grows a 5 to go there. So 7.2335. And this grows a 5 to go there. So 7.2345. So your lower bound and your upper bound. Okay, so that's that part over with, and now we're going to have to think about what we're going to do with this by looking at this calculation. Okay, so let's have a look at this. We've got a divide, and we're going to try and figure out the maximum value that we could get from this calculation and the minimum value. Okay, now with a divide, to get the biggest value possible, you want the biggest possible number on top and the smallest number on the bottom. So you want the upper bound on top and the lower bound on the bottom. That'll give you your maximum possible answer. For the minimum one, you want the smallest number on top, so the lower bound on top, and the very biggest number on the bottom, so the upper bound on the bottom. And those combinations will give you your extremes for the actual answer. So the very smallest answer it could be and the very biggest one it could be. And then we have to make our mind up which is the right one to have. So let's have a look at that. So let's do our maximum value. So the maximum value we said is the upper bound for x. So where's x? X is this row and that's y. So upper bound for x is 25.425. The lower bound for y is that, so root 7.2335. Okay, and the minimum value it could be is the lower bound on top for x, so 25.415, and the upper bound on the bottom for y, so 7.2345 in a root. So let's work them out. So 25.425 over root 7.2335. I'm just going to write it all out. Okay, and then change it for this one. So what we got here, so 4, 5 on the bottom, and 1, 5 on the top. So we've got 9.44900099. Okay, what we're going to do is we're going to look at these values and see where they're the same. So they're the same for 9, they're the same for 4, and they're not the same now for the next second value, because that's a 5 and that's a 4. But if I cut that value off, if I cut the values off there, that would round to 9.45. This would round to 9.45. So that's where they would be roughly the same. So 9.45 is a suitable degree of accuracy because it's true for the biggest answer and it's true for the smallest answer. Okay, and therefore it's going to be accurate whichever one you pick. So there is a lot to that one, and it is worth 5 marks, so there should be a lot to that. But the process is pretty much the same. It is a routine thing. Okay, so do the bounds first. Decide how you're going. If you need the upper bound or the maximum value, what you're going to use to do that. If you need the minimum, what you're going to use to do that. Okay, considering that there is important. Okay, next one. And I think it must be nearly there. Oh no, it seems like there's loads of them. Okay, and there's some big questions coming up as well. So I'm just going to pause it so the videos aren't too long. That means it can transfer quickly because it's a right pain. We have to wait for them.